Hey, welcome back, guys. Just reaching the end of the week here, and we're going to try solving polynomial functions, but this time they're going to be unfactorable, not like they were earlier in the week where you could apply some form of algebraic factoring. So, if you look at this as an example, if you look at this first function from the worksheet posted, if you notice, there's not four terms in it, so factoring by grouping isn't really going to work. Can't pair the terms off. There's no GCF. It's not obviously not a trinomial or a difference of two squares. So there's really no factoring method that you have at your disposal to try to work that out. So how are we going to figure out like an algebraic process to find the roots to this? Well, we're really not going to get a solely algebraic process. What we're going to have to do is use the graph of the function and potentially any of its rational roots that we can find on the graph, and then use those rational roots to synthetically divide them out, thereby reducing the degree by 1 degree each time. That's what it looks like down here. And then eventually we want to get down to a second degree. And then once we get down to a second degree, we can either try to factor what's left, or if it doesn't factor, or if it's just easier not to factor, we can use the quadratic formula. So starts out as a fourth degree. That means there's got to be four roots there somehow, some combination of four roots. It could be four rational roots. It could be two imaginary roots and two real rational roots. It could be two irrational roots with two rational roots. But the graph will help us find the rational roots that we can then synthetically divide out. So what I'm going to do is I'm going to take the calculator right here. And if you look at the calculator, I'll put it on this side so you can take a look. What I already did was I input the graph. Okay, so you can see the first equation is in there in y1. I have other equations in there later just to save me time, but the first equation is number 1. And if we look at the graph, we just go zoom standard, zoom 6. And if you look at the graph, you'll see a picture that looks something like this. Now, to me, it looks like potentially there's a intersection right there at -2, which would be a rational root. And then it looks like there's another one right here that looks like +2, perhaps. It's hard to tell. Obviously, we could zoom in and be for sure. Or we could just look at the table of values and try to find the rational roots on the table of values. And if we scroll back, you'll notice that right there is a root at x equals -2. So if we use -2 as an x value to synthetically divide out, we could drop the fourth degree, which is where it starts, down to a third degree. And then once it's down to a third degree, we could take another rational root, like this one, for instance, x equals 2, and we could take that remaining third degree and drop it down to a second degree if we synthetically divide this one out. So that's going to be the process that we follow. I'm going to start with the first rational root that I saw on the graph, -2. I'm going to divide it out synthetically. Then what I'm left with is going to be 1 degree less. A fourth degree turns into a third degree. And I'm going to then divide this next root out a second time. And then what we're going to be left with is a second degree function that we can then just use the quadratic formula to finish out. So let's see. I might have to split this into two videos. But if we start out using -2 as our first root, we know because of the picture, make sure you're careful to check that all power terms are represented in the polynomial function. Okay, so since they are, we have a fourth, third, second, first, and 0 degree terms. So we're not missing any. So then we've got the coefficients, 1, -6, 3, 24, and -28. And I'm already expecting this remainder to be a 0 because I know that that was a root on the graph. And so if it's a root, the output should be 0, which is the same as the remainder. So we add straight down, we get 1. Multiply diagonally, we get -2. Add straight down, we get -8. Multiply diagonally, we get +16. Add straight down, we get 19. Multiply diagonally, we get -38. Add straight down, we get -14, but if we multiply diagonally, we get +28, and therefore it's 0. So that kind of checks out. It's what we expected. So what this means right here is we changed a fourth degree down to a third degree by dividing out. And so we're left with x cubed minus 8x squared plus 19x minus 14. And I'll pick up on the next video of how to continue finishing this out.